Today's Geeks problem of the day is binary matrix with at most k ones. The problem is tagged with dynamic programming, binary search, and there are three more tags: searching, matrix, and the divide and conquer. I have solved the problem just now. Let me go through my solution approach and explain it a bit. So the problem, the problem states that you are given a matrix with R rows and C columns, where each of the element of the matrix will be 0 or 1. Find the largest square that can be found with center ij and contains at most k ones. There are q queries, and a single query has two integers denoting the center ij of the square. So you are required to implement the method largest square, which takes actually these parameters. The problem statement doesn't say about the individual queries, but yeah, these are the actual parameters that are given to the pre pre-given template method, and you have to return array list of integers for each of the individual queries. To solve the problem, I have first created cumulative sum of matrix. So basically, for each of the indices ij, I have computed partial sum. So basically, cumulative sum from 0 to ij, and using the cumulative sum array, I have done the binary search and found the result of individual queries. So first, the point to note here is for the uh, each of the query, the output will always be containing. Okay, so there is one special condition for k equal to 0. Other than k equal to 0, the result for all the result will be odd square size value. So basically, the reason is if the center is given as a single cell, then it it must be a odd sided square, because if it is a even sided square, then there are four centers, but we are given only one center, right? So for each of the query, the result will always be odd value. For k equal to 0, the special case where if mm, if there is no solution, so the number of sides in the square will be 0. So that is the only special case here, and that is also not a special case per se. But anyways, yeah, the expected complexity here is O of R into C plus Q into log of mean distance. So mean distance is like, suppose the center is this one, uh, 1 comma 2. The mean distance will be actually 1, because uh, here the distance is 2 from this side. The distance is actually, sorry, for this case the mean distance is actually 2, sorry, not 1. Here the distance is 3 from right side. The distance is 3 from bottom side also. The distance is 3, and from top side it is 2. So mean distance is 2. So the expected complexity for each of the query is q into log of mean distance plus r into c. So this, yeah, so for each of the queries, we will be passing the already pre-computed cumulative sum array, which is found with this logic. So suppose you already know the prefix sum up to ij. You already know the prefix sum. Sorry. Suppose we have to find. Suppose this is the ij value. So if you already know I minus 1 j result and I j minus 1 prefix sum, then using these two values. Okay, so while calculating up to this one, we have already calculated up to this one. So the cumulative sum for ij will be cumulative sum up to I j plus 1, sorry, cumulative sum up to I plus 1 j plus 1 equal to cumulative sum of I j plus 1 uh, I plus 1 j minus ij minus cumulative sum of ij plus uh, value at cell ij in the original matrix, which is m dot get I dot get j. So the reason here, the reason for this subtraction is because when we added this particular cumulative sum result and also this particular cumulative sum result, then we have added cumulative sum up to uh, I minus 1 j minus 1 twice, right? So in this particular array we have just used I plus 1 instead of I. So here we are subtracting this particular value because it was counted twice. Okay, now this this is the common logic for finding from cumulative sum of submatrix. Uh, yeah, so if you are required to find the sum from R1 to R2 rows and C1 to C2 rows, then we can get sum up to this. Suppose this is R2 and suppose this is R1. So sorry, R2 C2, R1 C1. Okay. So since in the cumulative sum array we have already used one based indexing instead of zero based indexing, but in the parameters we are assuming that these are zero based indexed. So cumulative sum up to R2 C2 up to this one minus cumulative sum up to this value minus cumulative sum up to this, then the we have to add this one one time because this was subtracted twice. Okay, so this will be the result of sum submatrix sum from R1 C1 to R2 C2. Okay, now for finding the largest square for a given query, so for a given query we have ij cell index and k is the total number of ones in the submatrix. Okay, basically the submatrix is the target square we have to find. Okay, so here we have used the binary search. So low will be okay. So in the binary search, I have just expanded from given cell in all the directions. So basically, if the result comes, if the mid value for the current iteration is suppose 2, then it will be 2 from sorry, let's assume it's 1 because the example matrix is a bit small. Okay, so suppose the given cell is this one for the current query. If the mid value is 1, then it will be representing this particular square, basically from here to here, because one if mid value is 1, then it means one unit in all the directions. 2 means 2 units including 2 units excluding the current cell. in all the directions. So the size of the square, in case the mid value is 2, will will be 5, because 2 into 2 plus 1, 2 from top direction, 2 from bottom direction, and 1 itself, and similarly, like that in all the directions it will be that much. Okay, so for each of the submetrics, first we have found the square submetric sum for the cells from I minus mid, j minus mid to I plus mid to j plus mid. Okay, one more thing is, if uh, if there is no solution, then the resultant size of the square will be 0, because if suppose k equal to 0 is given, and there are no submatrix, no cell in the matrix, the cell ID is 0. So basically, for given center, if the value doesn't contain 1, then sorry, if the value does contain 1 for all the given cells, then it, we can't have submatrix sum equal to 0. So that's why result equal to 0 is there. Okay. Now, if the sum is less than equal to k, then it is one of the possible solution. So a result based on the current mid value is set with result equal to 2 into mid plus 1, because uh, this particular mid value will be in all the directions plus current cell. So that's why the square side will be 2 into mid plus 1, and the low value, next low value we need to check will be mid plus 1, because we have already checked for mid equal to, sorry, low equal to, sorry, for current value of mid we have already found the solution. So next we have to check is for the low equal to mid plus 1. If sum is greater than k, in that case this is not a valid solution. So we haven't done anything, any changes in result, but high is set to mid minus 1, because mid, for current mid, there is no solution, and we have already checked for current mid value. Finally, the final value of result is returned from here, and this result is added in the result list. Finally, this result list is returned as solution. So let me just turn it again and show. I have already submitted it and it had got accepted. But yeah, so this was my second attempt actually. Okay, so this concludes our solution. Please like, share, and subscribe if it is helpful to you. Bye. Thank you.